Welcome to the video recording for XTC201, an introduction to Calabash. I'm your instructor Glenn Stevens, and to make sure you follow along with the labs, please make sure that you've downloaded the materials from university.xamarin.com. Okay, let's get started. We have a lot to go through today. We're going to introduce you to behavior-driven development, also known as BDD. We'll learn about Cucumber and the concepts behind it. We'll apply BDD to create Cucumber scenarios. We'll learn how to use some of the built-in steps to write tests against an app and then execute those tests on our local devices or simulators. Finally, we'll look at how we can write step definitions to turn the human-readable domain-specific language tests into executable tests. So we've got a lot to go through today in the next couple of hours, so let's begin. Our first objective is to look at the Calabash tool and its associated tools. Calabash is an API that's used by a tool called Cucumber. And Cucumber is a tool that we use in order to define domain-specific language-based specifications and then improve the quality of our application by converting those specifications into tests. To do that, we'll look at the fundamental concepts behind behavior-driven development and see how the tools are connected. We'll talk about behavior-driven development, Cucumber, Gherkin, and Calabash, what they are, and also how they relate to each other. To get started, let's talk about what you'll need to have installed. And there's two ways to use Calabash, a full local install and also using the Calabash sandbox. The first approach is to install all the required pieces locally on your machine, and this includes Ruby, the Calabash gems, and the Xamarin Test Cloud gem. And you can install all of these onto either Mac OS X or Windows. And we've got a set of walkthrough guides available at the link shown here on the slide. Just navigate to this page and then click on the Configuring Calabash link and locate your operating system instructions. If you're on Mac OS X, you'll be able to run tests against iOS and Android. If you're on Windows, you'll only be able to run tests against Android devices or simulators. Keep in mind that for Windows, you'll only be able to test Android devices. For those of you running on Windows, you'll only be able to participate in the Android portion of the exercises, as iOS needs to launch Instruments, which is only available on the Mac. An easier option for those of you using Mac OS X is to use the Calabash sandbox. And this is a pre-built environment but has everything you need already installed. And it's installed using curl and brings everything down as a single package, which you can then run using terminal. And this is the preferred way to get started with Calabash if you have access to a Mac. And if you're on Windows, this won't work for you because it really uses a bunch of Unix-based scripts. You'll actually need to do the local install in order to work with Calabash for Windows. Many of us here are from a software development background, and as a result, you might be used to writing tests that verify the technical aspects of a project, such as unit testing the internal classes that are defined for a system. Now, behavior-driven development, or BDD for short, helps communication between developers and subject matter experts. And BDD fundamentally allows you to capture specifications based on the behavior of the end users or customers. Behavior-driven development helps to develop specifications in a human-readable language designed for a specific business area. And this narrow language, which has terms and phrases agreed upon by developers and non-developers alike, is known as a domain-specific language, or DSL. And this DSL can then be used to write acceptance tests or specifications for the application. And given appropriate tooling that understands the DSL, we can execute those specifications too. And Cucumber is one such tool that allows us to capture those specifications, take that information, and then create executable tests against the specifications. And Cucumber tests are written in a syntax called Gherkin, and the basic Gherkin syntax is the given, when, then format that you see on the slide. We'll talk a little bit more about Gherkin later in the video. And this results in clear communication that defines exactly how the application should work in a way that everyone can understand, as well as testing that's focused on the real use of the application, which is the most important aspects according to the users. And it's worth noting that even without the third step, where the tests are executed, then the process has significant value because it clearly defines what the application must do and how it behaves. I mean, how many times have you worked on a project where you haven't had a real clear specification? Cucumber allows for us to create BDD style applications. It allows for the specifications to be captured in human readable format that captures what's really important to the customer. By capturing what's important to the customer, we get an important benefit of then writing tests that are focused on the needs of our customer. And this means we often don't create tests that are unnecessary or get sidetracked on other features that don't really exist. And you can see an example of a feature file that could easily be understood by anyone. And a feature will normally have a name and description along with multiple scenarios. Here you can see a feature file that shows how we can add a new task to our task management tool. And you should imagine the list of scenarios for removing a task, editing a task, or any number of task-related scenarios. The feature files are written in a syntax called Gherkin, and Gherkin defines the format of the feature file and includes the semantics of how to define the features and scenarios such as given, when, then. And we'll look at Gherkin in more depth throughout this video. And often these features may contain words or phrases that are unique to the industry. And these are referred to as domain-specific languages, or DSLs, and each industry will have terminology and other details that are very unique to them. No doubt the industry that you're developing your application for may have its own unique language as well. And many of the concepts in Cucumber can be boiled down to the following. We have the Gherkin grammar rules that allow us to write in a domain-specific language that defines the behaviors we need to put into our feature files. And this will consist of the name of the feature and the background or description of that feature. In addition, the feature will also contain one or more scenarios that state what will be tested in the feature. And scenarios contain a series of steps that determine the context the scenario is run in, what actions to perform, and also how to verify that the scenario was successful. These scenarios are designed to be run independent of each other, which means that they'll run in an unknown order regardless of the context and should be repeatable. And it's worth noting that the scenarios can be localized into a large number of languages. And the steps define the acceptance criteria for the test and how the application should behave after an action's been executed. And this primarily takes the form of given, when, then. And these scenarios would contain a series of steps that define what the scenarios do in a domain-specific language, and these steps make up the fundamental building blocks of the specifications. And part of the magic of Cucumber is that it allows an association between the step and a handler to execute when it encounters a step. We call these handlers step definitions, and each step definition takes a regular expression that matches the step and also the Ruby code that would execute when the regular expression of the step is encountered. The Ruby code would then interpret the code, query, or execute portions of your app and then continue on. For mobile apps, that execution of the code would refer to Calabash, and Calabash is an API that allows for automation and examination of mobile phone user interfaces, which would then run the command and inspect the visual aspects of the application on the iOS or Android devices. So what is Calabash? Calabash is an open source Ruby API that allows for automation of mobile devices or simulators. And if we have a Cucumber feature and a series of steps, as you saw in the previous slides, it'll be converted into executable Ruby code that'll control a mobile device to facilitate UI test automation. Cucumber will execute the scenarios in the feature files, and for each line in the feature file, it'll execute some Ruby code. And when it does, if that step needs to control your mobile device or emulator, it'll call upon Calabash to do it. Let's go through the process of setting up a project that'll contain a series of feature files. And to enable this, we'll need to set up a Cucumber project for our iOS application and another for our Android application. To do that, you would use the Calabash tools, which include the ability to generate the feature folders with all the associated files for the corresponding platform. And there's two variations of these tools, one called Calabash iOS and another called Calabash Android. Passing a parameter of gen will set up the feature folder. After this folder has been created, then the structure is in place for you to edit the features and their scenarios. Okay, for our first exercise, what we're going to do is we're going to set up our folder structures so we can run tests using Cucumber and Calabash. We're only doing the setup part right now. what we're going to do is we're going to navigate into the particular project folders. Now, if I look at my Part 1 resources for this particular exercise, you can see I've got a Part 1 starter folder. It's got the Android folder containing the Android APK, and also an iOS folder containing the Tasky iOS app. And what we're going to do is we're going to change into these appropriate directories first. But before I do that, I want to run the Calabash-sandbox tool. And that's going to enable the Calabash tools for me to use. Now at this point, I want to change into that directory. I'll just change into the starter folder. And then at this point, I might just change manually into the Android folder. And then I'm going to run the Calabash-Android tool. And I'm going to pass in the parameter of gen. And that's going to generate the folder structure that's needed so I can run Cucumber tests. So I'm going to hit return here. It's going to ask me to confirm that I want to create that features folder. I'll hit return again, and then the folder is created. Now if I navigate to that folder in Finder, you can see there's a features folder with a single feature file and some Ruby code there as well. And that Ruby code is actually specific to the Android platform. Now if I navigate back to the iOS folder, I can do a similar thing. I can use the Calabash-iOS and then pass in gen, and that's going to create the structure for the iOS project. So it's going to create a features directory here. Shall I proceed? Well, the answer is yes. I want to create a gem file for you. Shall I proceed? Again, we'll select yes. And then that folder structure has been created for iOS. So let's go ahead with a flash quiz. Calabash is a framework for A, creating specifications, B, testing applications on iOS and Android devices, C, defining the steps in a scenario, or D, managing configurations for tests. And the answer is B, testing applications on iOS and Android devices. Question 2. Cucumber allows you to write specifications only. True or false? And the answer is false. It also allows you to execute those specifications. We've now had our first introduction to behavior-driven development, Cucumber, Calabash, Gherkin, and all the related toolings. So we're going to be building on this knowledge for the rest of the class. And so far we've introduced you to the concepts for Calabash. Now let's take a deeper look at the features that will eventually be converted into executable tests. In this objective, we'll help define features and scenarios, how we write them, and also how we execute them. And we'll start with features. So let's look at features in a little bit more depth. Now a feature file uses the Gherkin syntax, and the feature file will contain a name and an optional description for the feature, and then a series of scenarios. And each scenario consists of a name, a description, and then a series of steps that will eventually get executed. And a feature file lives in the features folder that was created when we ran the appropriate Calabash tool, either Calabash iOS gen or Calabash Android gen. And the file ends with the .feature extension, and once added to the features folder, it becomes included as part of the test suite. So here we can see the structure of a feature file. Now let's break it down a little further. So each feature file will have a feature name, and in this case we'll have it set to task management, and underneath that we'll have an optional description for the feature. The description outlines what the feature is describing, and it can be any text except one of the keywords such as given, when, then, and, but, or background. And in case you're wondering, Gherkin uses white space and uses indenting to define structure. Now it doesn't matter if it's a space or tabs as long as the spacing matches. Now below that we have a list of scenarios for the feature, and each scenario will have a name and then an optional description. And underneath that we have a series of steps that constitute the scenario. And these steps take the form of given, when, then statements. So the given represents the context in which the scenario is executing. The when keyword represents the actions that will be performed. The then keyword is used to assess that the actions that were performed resulted in the outcomes that were expected. And notice that this is very similar to the arrange, act, assert steps that we took when we were writing NUnit tests in XTC201. So keep in mind that the steps defined in the scenario won't automatically do what you want. They either need to map to existing steps defined in the project, or we have to define them. There are a series of other keywords in the Gherkin grammar, such as and but, and these represent additional steps that can be executed and help you to keep the scenario readable. But there's also an additional keyword called background, which allows you to specify steps that are executed before each scenario. For example, if I was on the task screen for all the scenarios in this feature file, it would make sense to create a background scenario and then move that given statement to the background scenario. And that way the individual scenarios become easier to read and more manageable. Each step in a Cucumber scenario will eventually be run through Ruby as a step definition, and Calabash already comes with existing definitions that allow you to perform some actions against the device, like you can see on the screen. And the predefined steps that you can see here also allow you to do things like save a screenshot of the current device, tap on the first button of the screen, and you'll actually find that the Calabash predefined steps are all 1-based. They're not 0-based like the coding conventions that we're used to. We can see in that third step where we're entering the text John Smith into the first input field, and also in our last step we're hitting the back button. And when you install Calabash, it'll install several tools on your machine, and each of those tools will be used to run Cucumber to perform the tests. And each of those tools will use information that's either passed via the command line arguments for the tool or environment variables that are defined for the current console session. When we run the iOS app, we define an environment variable called app_bundle_path to be the location of the app file, and then run the Cucumber tool. For Xamarin developers, you'll find this in the iPhone simulator bin folder. The Cucumber app will run the app and then apply the tests against that app. This will load the app onto the iOS simulator and run through all the scenarios in the feature files stored within the features folder. Likewise, Calabash ships with the Calabash Android tool that allows you to execute the tests. However, there's an additional setup required when you're executing on Android. You'll need to ensure that your environment should be set up to talk to the appropriate key store. A key store is a certificate signing mechanism used by Java and Android that's used to verify who an app is developed by. And you can find more about key stores in our AND 220 video course. So you'll need to set up your key store using the Calabash Android setup. And this will prompt you for the location of the key store and the alias and password used for the key store. For our example, we're going to be using the XAMU example key store file and the alias Xamarin and password Xamarin, all in lowercase. After that, you'll need to reassign the APK file using the same key store as the test server. And this can be done by using the Calabash Android reassign, passing the APK as a parameter option, like you can see here on the slide. So use the Calabash Android with the reassign option, followed by the location of the APK file. You'll only have to do these two steps once in order to make sure the APK file is in the correct format. And then to run the application, you'll use the Calabash Android run, passing in the APK option, to run the test against the APK, and the test should execute and you should see the scenarios run in your emulator. It should be noted for Android though, in order to execute tests, unlike iOS which launches the simulator for you, on Android you need to actually have a device or emulator running and connected to that machine. When working with Calabash, you may also want to work with profile files instead of simply executing the tests. So rather than execute the command line arguments every time, you create a cucumber.yml file in your config folder. You can then specify profiles that determine what arguments will be specified, such as the app bundle path for iOS tests, but also the device and any other configuration settings that may be used. So there are more settings for the configuration files. In fact, follow the link that you can see on the screen to find more. So now, spend some time going through the individual exercise on setting up Cucumber and creating some features. Go through the labs, and when you've finished, we'll review. Now, the main goal of this exercise is to ensure really that we can successfully create and run Calabash tests on your system using predefined steps. Now, it's also going to ensure that you can test and run the acceptance tests on your own platforms as well. So the first thing we're going to do is I'm going to continue on using the sample I had in the first project. What I can see here is I've got my feature file here. It's called My First Feature. That's not really appropriately named, so I'm going to rename this file just to something a little bit better called Task Management. Now, once I've done that, I then need to edit the feature. So the feature is really going to be for Task Management. So I'll change the name there. I might even give it an optional description. So my description might be something along the lines of, I want to be able to edit, delete update and manage my tasks. And then we've got a series of scenarios. So the scenarios act really like individual tests that you execute. So my first scenario that I'm going to run today is really testing adding a new task. And then I've got my individual steps that I want to execute. So this is really going to be a series of things that I do in the application. So I'm going to use, when I press add task, then I probably need to enter some other text. So, and I enter get milk. Then I enter get milk into input field number 1. And I enter get half and half into input field number 2. So that adds the name and the description. And I press save. So there's a little bit of code completion coming through with the Ruby Mine tool as well. So then I should see get milk in the task list. So that's the Android test. I've updated the feature file. I'll just go ahead and save that feature file. Okay, my next step is to actually go ahead and execute the tests. So heading back to my tools, I've got my Android emulator here on the right. Now it's important when you run the Android tests that you actually have an emulator running or you have a device connected. If you're running iOS, iOS will actually launch the emulator for you. So I'm heading back here, make sure I'm in the right folder, change to the Android folder. And then what I want to do now is I want to just run the individual tests. So I'll call Calabash Android, then I'll call run, and then I'll pass in the APK. So there's a few things that I need to do with this particular application. In fact, the application is not quite set up. This is quite common to see this. So I'm going to take you through the individual setup parts that you need to do. So first, we actually need to set up the folder. And if I look at the individual files, I've got a key store within my folder as well. So one of the important steps to run with Android is Calabash Android setup. And then it's going to ask you where the key store is. I'm just going to type in the file name, XAMU example.keystore, and enter the password for the key store. Well, this is all Xamarin lowercase, and the alias is also Xamarin lowercase as well. So then I need to also use the Calabash Android resign and then pass in the Android package name. I hit return there. It'll go ahead and resign the application, and then I should be able to go ahead and run those series of tests again. So I use the Calabash Android run com.xamarin.samples.taskyandroid.apk. So it's implementing the features. It's about to launch the application. We should be able to see it in the emulator right about now. And then it'll go through the steps one by one. Cool. And all those steps ran perfectly well, and we can see in the output that's all green, which means it's good to go. So now you've seen what features and scenarios are, as well as how you can execute those features. So let's move on to looking at how to use the Calabash API with Ruby to write executable tests so that we don't use the predefined steps. In this objective, we're going to run through writing step definitions in Ruby, dealing with exceptions, and also how to interact with the user interface. So don't worry if you don't know too much Ruby, as we'll be looking at the tooling that can help us with a workflow, and you'll actually find that the tooling does a lot of the work for you. So let's start by looking at step definitions. So creating steps and step definitions are the ideal way to create your features and scenarios. And the core issue with predefined steps is that they're simply there to help you get your initial tests set up and running quickly. However, using the predefined steps is not considered best practice, and has been mentioned throughout the course that the main benefit of Cucumber is that it's designed as a system for writing specifications which result in clear communication using a domain-specific language in collaboration with a subject matter expert. So these predefined steps don't use the DSL. Instead, they often refer to control names or positions that result in more lookup of the user interface, and they're quite limited really. And if you want to create maintainable tests, you should write clear steps that have them execute using natural language or a domain-specific language. Step definitions use the Cucumber API to register handlers for what happens when a step within a feature is registered. And for every step you have in a scenario, there needs to be a corresponding step definition that contains what code to execute when it encounters a particular style of step. On the left-hand side, we have the step given I have logged in. And on the right-hand side, we've got the Ruby code that will be executed whenever Cucumber encounters that step. Here we have the details of another step definition, and this time one where we have a parameter defined in quoted strings. And since we're using a regular expression to define the step definition, we can match even though we have a quoted string. By using parameters with step definitions, we can actually create more reusable scenarios and also can write more efficient steps. So keep in mind that you still need to make sure your scenarios are written clearly for effective communication. So how do we handle these regular expressions? So using the Cucumber minus dry performs a dry run of Cucumber. And a dry run checks that you have all the appropriate step handlers, and for ones that you don't have, it'll actually generate the handler code for you. And this is considered best practice to create the step definitions this way, as the tooling will help you, and you don't have to do the heavy lifting of defining those regular expressions. Now, a lot of integrated Ruby IDEs also have this mechanism built in too. Now, apart from missing step definitions, the core reason that a test would fail is if an exception occurred while executing the tests. Now, you have the choice of either raising an exception yourself within the step definition, or more likely what you'll do is use some of the built-in Calabash assertion functions that allow you to determine some of the common situations when UI testing. So these assertion functions methods include things like fail, check element exists, check element does not exist, and check view with mark exists. And using these methods allow you to ensure that the user interface is the way you expect. As Calabash is a cross-platform UI test automation framework, it allows you to take control of mobile devices and perform common actions on the user interface, such as tapping, entering text, gestures, and querying the user interface of the application. Over the next few slides, we're going to look at some of the common Calabash API calls that you'll use to control and query your devices or simulators. So let's take a look at what's going on when you use Calabash to test your mobile applications. First, we have the Calabash clients. And these are the test frameworks such as Calabash Android and Calabash iOS. And the clients communicate with a Calabash server, which would be running on a device or a simulator or emulator. And even when we look at the test cloud server, the Calabash server will be on a separate machine from the device. So it's important to keep in mind that your Calabash Ruby code is not executing on the device itself, but from a different machine or system that's controlling the device. But at the heart of most Calabash API calls is the Calabash query language. And the query language allows you to find which control that you'll be interacting with on your mobile interface. And the query syntax is actually similar to a CSS style selector that allows you to examine the elements of the user interface and then return a list of controls that match the query criteria. And you'll find that there's many operations that will perform using Calabash, such as looking for user interface elements, entering text for data-centric applications, and more. And we'll also look through some of the common challenges when working with Calabash over the next few slides. And here we can see some of the common queries that we might use when inspecting our application. So queries are based on the details of the application. And much like other languages like SQL and CSS, ideally, you want a utility where you can try out the queries and see that they're executing well. So the same Calabash tools that we use to generate the feature set can also be used to execute queries against the console. So you can see some examples here. We've got the query star, that'll return all the visible elements. We've got the touch, and that'll tap on a button marked saved. So marked represents the identifier or the string. We've got a query against the UI text field and at index 1. So that's going to return the second iOS text field. So when you're using the Calabash API, it's actually 0 based. We've got another query where we're looking for the android.widget.edit text. So it'll return all the elements of that type. And in fact, all subclasses of that type too. We've got another query below that that'll look for all the Android elements with the class name edit text, regardless of the namespace. There's another command that'll flash all the buttons on the screen, and another query that'll actually look for the web views. And we have another query that'll actually look for all the anchor tags within a web view. It's also helpful to think about what you're doing when you're using a mobile device. And if you look at the fundamentals, then you're probably only doing several things anytime you use an app. And you're probably tapping on some control, entering text into those controls or making selections, waiting for things to happen, or maybe even just doing some gestures. And we're going to look at some of these common situations over the next few slides to give you an idea of what you need to do to create a test. And it'll also give you the foundations for some more complex tests too. So let's look at our first example, entering some text into a text control. So we can do this by selecting a control and then entering some text into that control. And you can see on the slide, we're selecting the control that we want to use first by tapping on that control. And that control then becomes the active control. And then depending on the device type, you might see a virtual keyboard appear and then enter the text on that control. And if you've already got text in a control, a simple way to replace the text is to use a variant of the query operation, passing in the selector and then the text that you want to replace it with. When testing mobile apps, it's very common to have controls and elements appear and disappear from the screen. This could be the result of an animation, or it could simply be changing the visibility of a control based on data or user interaction. So when you're writing and running your tests, it's not recommended to wait for a specific time when waiting for an operation. Different devices will have different capabilities, such as CPU speed and memory, so they'll have different timings as a result. Instead, a better option is to wait for a particular condition to occur. Now in the example on the slide, we're waiting for an element to exist on the screen and then setting a timeout of 5 seconds. And this allows us to ensure that the element's visible on the screen and available to interact with in our test. From time to time, you'll also need to control access to web views. And you may have embedded web views in your application, or you may be using something like an OAuth provider like Dropbox or Facebook or Twitter. Because you're using one of those providers in your application, you might need to present user authentication detail. So in order to test those situations, you'll very likely need to automate the UI, and you can do so by using the web view in combination with a CSS entry. And you can see here that you can also send JavaScript commands directly to the web view for further control through the Calabash API perform action command. And with these commands, you can have complete control over the embedded web browsers within your application. We've now learnt the basics of the query API that I'll be using to check or execute actions on the various controls. And you'll actually find there's a range of different methods that we can use. We've got the ability to query or to examine the user interface elements. We can tap and select a control. We can enter text. We can be able to manage the text on an editable control. We can wait for a particular element to appear or disappear. We can perform horizontal swipe controls. We can do scrolling operations, which is really essentially the swipe operations but vertical. We've got location tracking, so we can emulate the application being used at a specific latitude and longitude. And there's even backdoor access to the application. And this can be used to speed up tests by having a command that resets the app instead of uninstalling and reinstalling, which is what's used by default. And remember that your test should run as fast as possible. We've also got APIs for taking screenshots while you're running the scenarios. And we also have assertion checks, so we can check that a particular condition is occurring and raise an exception if it isn't. And you can see the full list of APIs for Calabash at calabashapi.xamarin.com. So let's have a look at how we can piece all these steps together. And we're going to be using the appropriate tooling. We'll be using the REPL, and we'll link our scenarios together so we can actually execute it as we go through. Now in this last exercise, we're going to demonstrate how to correctly create and use feature files. Now we'll look at how to write reusable handlers for the steps defined within our scenarios. And in fact, in the previous example, we used predefined steps. And while predefined steps will actually execute some actions on the device or the emulator, the key problem is they're not manageable, they're not maintainable, and they're hardly readable as well. If I look at this particular step here, for example, and I enter get milk into input field number 1, if I didn't know what the application looked like, I would have no idea what input field number 1 is. And ours is a very simple application. So if you're creating more complex applications, as I expect you would, you'd actually need to have something a little bit more readable and maintainable. And what I mentioned before about having tests written in domain-specific languages is very relevant. You want to make sure that you're actually communicating in the language that both the users and the developers understand. So what I need to do in this particular case is I need to change these steps to something that's far more readable. So instead of when I press add task, it's when I add a task. instead of, and I enter get milk into input field number 1, it's something like, and I name the task get milk. And I set the description of the task to get half and half. And I save the task instead of I press save. Then I should see get milk in the list of tasks. So already that scenario is significantly more readable. So when I add a task, I name the task get milk, and I set the description of the task to get half and half, and I save the task, then I should see get milk in the list of tasks. Now that's a very good example of a scenario that can be used in a specification. So let's go ahead and save this. But I do want to execute these particular steps as well. But right now, I actually don't have any code that will execute when I actually run these tests. When I was using predefined steps, what would happen is they would run Ruby code that's already written against those particular names. For this particular step, I need to do something a little bit different. So I'm already in the folder, and what I'm going to run is I'm going to run Cucumber with the option of -dry. What it's done is a dry run of the execution. So it hasn't actually executed the task. It's looked at what particular steps are not defined. And for those steps that are not defined, it'll actually create the Ruby code for you, or at least the handler code. And in those particular spots where we have parameters, it'll actually create the regular expressions for you to actually pass them in as arguments to those particular step handlers, like you can see here when I name the task. So what we're going to do is we're going to copy that Ruby code to the clipboard. We'll go back into our IDE. We'll have a look at the step definitions. I might just create a new file here. Let's call this task management steps. And then I'll paste that code in. So this is a great situation to be in. We've got all those tests. We just need to fill in the blanks of what we need to add into those particular items. So right now, we need to go back into the terminal just for a second. I'll just minimize that Ruby window. And what we're going to do is we're going to execute some commands against the application. So I can see here I've got my APK file. I'm going to run Calabash-Android again, but instead of using run, I'm going to use the parameter console and then pass in the APK file. And that will run IRB, or Interactive Ruby, but it'll also have access to the Calabash APIs as well. Now at this point, I'm going to call it start test server in background. And that's actually going to launch the application. That's going to enable me to communicate with the application. So I'll be able to send it commands, I'll be able to analyze the user interface. So I can use the Calabash query language. I can use something like a query star, and that'll return all the items that I have. And in fact, right down the bottom, you can see this item menu add task. If I want to simulate touching on that item, I can use the touch command. I can use the ID of menu add task. And it'll actually perform that step for me. And that's excellent because I can now copy that text into my Ruby code. So I now have my step handler for when I add a task. And I can go through the same process for the other steps as well. If I head back to the IDE, I'm on a new screen, so I'll need to issue another query just to find the controls that I want to work with. So at this particular point, I'll just scroll up. I'll look for the appropriate edit text that I want to manipulate. And in fact, I could probably just alter the query. So I can do a query edit text. It'll show me the items. So I've got one called text name and one called text notes. So in this case here, it's the text name I'm interested in. So I'll touch on the item called text name.
Excellent. So I need to copy that then over to my Ruby code as well. And the next thing I want to do is I want to use one of the keyboard operations. So you can see there's a few there, keyboard enter text, and then we'll call or pass in the parameter get milk. And that's entered the text there. Awesome. So again, I copy that text to the clipboard and then paste it into my step there. So in fact, this get milk actually should be the argument. So I'll rename that argument to task name and then use that argument to that step handler. And in fact, what you'll find is the description will be almost identical. Instead of text name, it'll be text notes. I'll call that description and pass that directly into the keyboard enter text. So the next thing I need to do is to actually save the task. So I really should go through and make sure I can do that. Let's bring the emulator back up. So I want to do a query. I'll just look for the buttons in this particular case. No, can't find the buttons. They might be another class in Android. In fact, yes, you can see it here. It's the action menu item view. It's not a button. But here we want to use the menu save task, for example. So I can issue a touch command. So we're looking at the ID of menu save task. Excellent. And that's actually created that for me as well. So again, I'll go back, paste this into my task window. Now, if you're using multiple monitors, it's obviously a lot easier to have them all open up at once and just copy between the windows. Just presenting this on a single screen, so there's a little bit of back and forward. Now, the last step handler that I need to implement is this one here. I should see a particular name in the list of tasks. So in that particular case, what I want to do is just check that I've got that particular text. So I'm going to use a query statement here. And I'm going to use the marked keyword. I'm going to use get milk just to see that I can execute that. And I'm getting a couple of results back here as well. What I want to do is actually use the element exists. And that'll take the same kind of selector, star, marked, get milk. And when I run that, it's executing true. If I had different text in here, maybe a double T in get, it wouldn't find it. In fact, it would raise an exception, which would mean that the particular scenario failed, which is actually the behavior we want. Now I've got my text that's running here, just the normal element exists, star marked get milk. I'll head back into the Ruby IDE and I'll paste that code as well. Now I do have an argument here, which is the task name, and I will need to replace that here as well. So I'm using the string interpolation that Ruby has. So I'm looking for an element to exist where the text or identifier is the same that's passed in as the task name. So that should be all the step handlers that we need to implement for this particular example. So I'm going to save that. I'll minimize the IDE. And I'll just get out of the console. And this time, I'm going to actually use the Calabash Android. I'll use the run command again and pass in the package name. So it should launch the application. We'll see that in just a second. Go through the steps of adding a task, setting the name and the notes, saving it, and then it should see the step in the list of tasks. And that's awesome. We've just created our first proper Cucumber feature file and then executed it on the mobile platform.
So congratulations, you've just successfully created specifications for the Tasky Pro application. So that's excellent. You've just seen how to create a scenario in your own feature file and then execute that against the device. Now, obviously, you can just add more and more scenarios to those feature files, create additional feature files in those folders, and they'll all get executed when you run your particular APK. So let's finish off with a flash quiz. Question 1. The Calabash query language, A, lets you check user interface controls against the data store. B, examines the user interface elements on the screen. C, queries the steps in a scenario. Or D, performs tasks on the user interface controls. And the answer is B, examines the user interface elements on the screen. Question 2. To query for a button on the screen with the text save, I would use A, button text equals save. B, label equals save. C, button mark save. Or D, table view cell text save. And the answer is C, it's button mark save. Remember, the marked operator is used to check against the text or the identifier for that control. Question 3. To test an application using the Calabash iOS, you need A, an application from the App Store, B, the Calabash library component linked to your application, or C, a features folder. And the answer is B, the Calabash library component linked to the application. So we've worked through a lot of material in this section, and you've seen how predefined steps are not a good idea, and that they should ideally be replaced with step definitions that line up with clearly written steps. You've also worked through an example of writing Calabash scripts dealing with the REPL and also understanding the common tasks that you'd use using Calabash. So in today's video course, we've been doing local UI testing with our simulated devices. However, to really try out the app, we eventually need to test it on a real device. So you can deploy these exact Calabash tests to real devices, and we'll cover that exact topic in the next class in this series, XTC103. Now, in addition to local devices, we also look at pushing these same tests up to a cloud testing environment, because as you know, there's far too many devices on the market and no way to adequately test that your application will work on the huge range of devices out there. So while exceptionally powerful in a local environment, the true power of Calabash lies in the fact that you can take a working local test case and push it to Xamarin Test Cloud with no modifications, scaling out your testing efforts across a pool of more than 1,000 real, non-jailbroken Android or iOS devices in a cloud environment built for performance and stability. So we'll look at how to take our tests and then do this exact same UI testing on a number of devices in the XTC103 class. So thank you for watching the Intro to Calabash video course. And we've learned a great deal about Calabash, Cucumber, and Gherkin as well, and how they work together to provide a great acceptance testing mechanism. And if you have any further questions, please email me at the email address on the slide. My name's been Glenn Stevens, and I look forward to seeing you in Xamarin University classes.